Good morning, students. Thank you very much for coming online today. Today we are going to be looking into water. One thing about water is that it is the most important chemical compound on Earth. It covers about 70 to 85% of the surface of the Earth. That means that that's very, very large if you can get the idea. If it is that large, it means that it's the most abundant, or we can even say common compound on Earth. Even in our body, we have it about 70 to 75% for healthy human. So, in this video, we are going to be looking into water. And I have the content of the video, which is classification of water. That is what we are going to be looking into here. We are going to be classifying water based on sources, the presence of deuterium, and also the presence of a special ion. Also, we are going to look into water as a chemical compound, and we're also going to look into water pollution. So I urge you to follow me as we go on one after the other. So classification of water under sources, we have isotope of hydrogen present, and we have calcium or magnesium ion present. And for sources of water, one of them is natural sources of water, and we have another one, treated water. So let's start with natural sources of water. We have rainwater, and we have spring water, we have well water, and sea, river, and ocean water. This is natural way we can actually get water. Yes, and treating them one after the other. The rainwater is said to be the purest form of water. This is because it is naturally condensed water. That means that it is formed by condensation of evaporated water from the surface of the earth. And any water formed from condensation is pure, and it is distilled water. So rainwater is distilled water. Yet it is not the best in drinking. So the question will be why? If I just say that that's the best and the purest form of water, then why is it not the best for drinking? This is because while the rainwater is falling down, it mixed up with dust in the air and also some gases which might be acid anhydrides. What I mean by these acid anhydrides are those non-metallic oxides that when they dissolve in water, they will form acid. Example of them include sulfur 4 oxide. If it dissolve in water, it's going to give us triazosulfate 4 acid. Nitrogen 4 oxide will do that, although in the presence of oxygen. Carbon 4 oxide will also be acidic. So if the rainwater mixed up with these acid anhydrides, it is possible that it will dissolve in water, which is highly possible, and forms acidic. And to confirm this very well, you notice that it normally falls on our roofing sheet. If you check most of our roofing sheet, it changes color. That is why we even introduce aluminum roofing sheet. And not even the aluminum roofing sheet is the case. We even use paint to paint that aluminum roofing sheet so that the acidity of the rainwater will not affect it a lot. I hope you get me on this. So spring water, for spring water, it is actually the best for drinking. This is because it contains minerals which are good for our health, mostly for our teeth. Well water is not good for drinking. It can just be used for doing other house choice, but it's not very good for drinking because it contains clay and dirt, and most times they normally dig it close to pit latrine, which is not healthy for us. For seas, rivers, and oceans, they may be contaminated by dirt, decaying organic matter, and industrial effluences. And you should understand that both the seas, rivers, and oceans, well water, spring water, and rainwater, all of them, since we might have some little problem with them, we can actually treat those water. This leads us to look into treated water. Treated water is actually said to be artificial water. This is water that either the chemist or the people are actually trying to work on. One of them is distilled water. Remember, this treated water, we are treating it based on a need. So for distilled water, the major reason why we are preparing distilled water is because it is needed in the laboratory preparation of reagents and analytical processes. Also, there are some certain industrial processes that will even need this. We have liquid in car batteries. It requires a distilled water. And we have preparation of drugs. That is for distilled water. We have pipe-borne water, and we also have chlorinated water. For this pipe-borne water, we have, how will I put it? We have processes by which we can get this pipe-borne water, and this distilled water just is a condensation of steam. That is where the distilled water come. But this pipe-borne water, we have processes which can use to get them, and we have it as one, aeration. Here the water and air are brought close to contact in order to remove dissolved gases and oxidize dissolved metals, something like iron, hydrogen sulfide, and other volatile organic chemicals, which air can help to oxidize them and it can be removed. And this also will help to reduce the foul odor of the water. Yes, this aeration will help to reduce that. The next thing is coagulation. In coagulation, what happens here is that we collect dirt by addition of aluminium by addition of potash alum, where we have as potassium aluminium tetraoxosulfate. Is a hydrated salt. So what this salt does is that it will form close contact. You form a close contact with dirt or some solid substance, and they will cluster together, which will lead it to sediment. So when it sediments, what happens here is that we can filtrate the water using filter beds. And the next thing is to add disinfectants. Something like chlorine can be added in order to kill germs, and fluorine can be added in order to help for tooth decay, and iodine can be added in order to help for gutter problem solving. And note this, bromine is not added. Bromine is the only halogens, the first four halogens that is not added in water. And also, you notice that I do not have distillation here in my processes for pipe-borne water. The reason why distillation is not here is because distillation is costly. It involves a lot of energy. You need to keep on heating the water. So because of that, we don't really do that for treated water. The next thing they do is to distribute it through pipe. Sometimes it can be from lead-free pipe. Sometimes it can be from lead pipe. If it is lead-free pipe, that means that probably there is a presence of there is no presence of calcium ion or magnesium ion. But if it is lead pipe, that means that there must be presence of calcium ion or magnesium ion. You will get me on that when we reach classification of water based on the presence of special ions. Okay, so chlorinated water, this one is just majorly for pool, or we can add chlorine for the pool. Although in our schools we can also have chlorinated water where chlorine is added in order to just to kill germs. So we go further to look into classification of water based on the isotopes of hydrogen present in the molecule of water. We have one we call light water and we have the other we call heavy water. Now you may be asking, what do I mean by light water? Light water is coming from the hydrogen that contains only one proton and one electron, which is protium. And for heavy water it contains deuterium. So if you look at this diagram, you will see the white represents hydrogen, the green represents the deuterium, the white represents just the protium. I hope you get me on this diagram. So I want you to use this opportunity to know that water shape of molecule is in V shape. Now if you look at this current diagram here, you will see where it is written simple hydrogen. You see how it is written 1 1, but the deuterium is written 1 2. That means that we have one proton, one electron and one neutron in this deuterium. I hope you get that. Okay, so let's look at classification of water based on calcium ion or magnesium ion that is present. Here we have it as either hard water or we have it as soft water. Then what do we mean by this hard water? For hard water, before water is said to be hard, it means that the water refused to lather with soap. So when you want to wash your clothes, you start to notice that the soap is not actually lathering very well. So the cause of this is because there is a presence of calcium ion or magnesium ion that are soluble. Example can be either calcium hydrogen triisocarbonate 4 or that of magnesium, or we can even have chloride or tetraoxosulfate 6 sort of calcium or that of magnesium. Now based on this ion, we can group hard water into two: temporary hard water and permanently hard water. Now in this temporary hard water, we have only hydrogen triisocarbonate sorts of calcium and magnesium, but permanently hard water we have chloride or soluble tetraoxosulfate 6 sort of calcium or magnesium. For temporary hard water, to treat this, what we have here is that if you just boil a temporary hard water, it will precipitate insoluble triisocarbonate of calcium or magnesium. I would like you to see how the equation look like. So if you look at CaHCO3 plus boil, actually this is supposed to be aqueous. Then the other one is going to give us solid. Solid means that it forms a precipitate. So you need to put it in your hand. Somebody can actually ask you to write equation of the boiling of temporary hard water. This is a simple way of writing it. Either you use the first one or you use the second one. And we have using of calculated slide lime, where we are going to have an equation that looks like this. Here the slake lime is added to the water and there will be an ion exchange where we are going to have insoluble triisocarbonate 4 sorts of either of calcium or that of magnesium, or sometimes it can be 2 of them. So what about permanent hard water? I said that permanent hard water is composed of chloride or tetraoxosulfate 6 sorts of calcium or that of magnesium. And how do we actually treat this? We have by using zeolite in ion exchange to precipitate insoluble zeolite of calcium or zeolite of magnesium. So this is the simple way of representing it in equation. And I just want you to know that except by distillation, all the process we are going to use to precipitate or soften hard water is actually from double decomposition or precipitation reaction. Yes, you need to know that. So the second one is by using caustic soda. It's also an ion exchange method to precipitate insoluble hydroxide of calcium or magnesium. Know that this ion exchange is actually the statement used for double decomposition reaction. Double decomposition reaction is a type of reaction in which ions are exchanged by two uh, electropositive ions. Yes, that is what normally happen here. Although one of them must be precipitated because one of them is not soluble. That is one of the products is not soluble. That is what happens here. This calcium hydroxide, I wrote it as S. That means that it is not soluble. I hope you get me. From that, we can actually do filtration to remove them. When we notice that they are insoluble, we are going to filtrate it. Please, I want you to know that this CaAl2Si2O3 is solid, not aqueous. Just note that, please. It's very, very important. Okay, we go by using washing soda to precipitate insoluble carbonate of calcium or magnesium, as you can see on the screen. Remember that this MgCO3 is solid, just like that my uh, aluminum trisilicate is insoluble when it comes to calcium or magnesium. And the last way of softening hard water is actually by distillation. As I just said in the process of pipe-borne water, I say that distillation is costly, so distillation might not be used generally, but just for at home, some people might feel like they prefer to heat it. But why should you even convert hard water? Because hard water has its own advantage and although also have its own disadvantage. So let's look at advantages of hard water. Advantages of hard water. We have that it supplies calcium and magnesium ion necessary for shell formation, good bone and healthy bones, and also good teeth and healthy teeth formation seen in animals. So if we are drinking much of hard water, we can be having good bones in our body because the calcium and magnesium supply will aid us in bone formation. Also, it doesn't dissolve lead pipe. This prevents lead poisoning. Remember I said that in distribution of water, if we are using lead pipe, we really need calcium ion to be present. So if calcium ion is present, it means that it will not allow the lead to dissolve in water. If the lead did not dissolve in water, it avoided lead poisoning. So for hard water will always help us to avoid lead poisoning. Lead is actually a metal. Yes, it's a metal, but it is not all that good for our body. 3, it tastes good. To be frank, that at place, this is TASTES. It tastes good. To be frank with you, soft water that has no minerals inside is actually tasteless. Yes, it's actually tasteless. But because of these minerals that are inside the hard water has taste that we can work with. Disadvantages of hard water. We have something like it wears soap. Actually, that's the definition of hard water, that it will not allow soap to lather easily, and it can be used for dyeing, even in tanning can be used for that. It causes fury on kettle for temporary hard water. In temporary hard water, if since we say you can just remove the the hard water just by boiling, it means that those people that use kettle to boil water, so sometimes you start to see something whitish at the bottom of your kettle. That is actually what we call fury or for. It is actually due to the precipitation of calcium carbonate 4. Yeah. Now, when sometimes they can ask you, can you write describe any experiment on how to know the level of hard water? The best way of determining the level of hard water is to use soap. So the number of soap that is able to lather in the water determines how much of calcium or magnesium ion present in that water. Mostly we use titration to do this. Okay, I would like us to look into water as a chemical compound. I know you may be saying that the video is taking longer. I'm sorry for that. Water as a chemical compound. We have to see that the water has two hydrogen atoms and one oxygen atom. The molecular mass of water is 18 gram, where H is 1, O is 16. If 2 times 1 will give us 2 and 16, if you add them together will give us 18 gram. I need you to know that. And the shape of the molecule of water is V shape, as you can see over there on the diagram. I want you to get that. So in the laboratory, we prepare water just by burning hydrogen in the presence of oxygen. That is what you have here, and this is a simple equation for it. You can make the equation better. You can check your notebook and see the better version of the equation. So physical properties of water, I just selected few properties of water. It is colorless, odorless, and tasteless liquid. That is what it is. This is only one point. And the second point is it boils at 100 degrees Celsius and freezes at 0 degrees Celsius. And its maximum density is seen at 4 degrees Celsius. And this density we are talking about is 1 gram per centimeter cube, or we can even say it is 1000 kilogram per meter squared. It has high surface tension compared to other covalent compounds. Chemical properties of water. So we have reaction with metals and non-metals. It means that water can actually react with metals. You have so many ways it can react with metals. For sodium, potassium, and calcium, they can react with cold water. When they react with cold water, they will form hydroxide and hydrogen will be liberated. But something like magnesium, iron, we need to heat them and also use steam to pass through it, not just normal water steam. But what we know is that it's the same H2O. We pass through it, we are going to have evolution of hydrogen. But that of ion here is actually a reversible reaction. So you should be careful on this. They normally bring something that look like this in questions. Reaction of water with non-metals, with halogen, we will have something like this. So you can actually change this Cl2 to Br2. You have close value of this. But if you use fluorine, as we did in our chlorine class, if you use chlorine, what you're going to see here is that if you use fluorine, what you're going to see is that it's going to form 2HF, and oxygen will be liberated directly. For group 4, the C here is going to be coke, and it's going to be red heated coke, and this H2 is going to be steam, and it's going to pass it over that. We're going to get what we call water gas, and you can see we actually use this process in production of hydrogen. If you look at the water reaction with metals and non-metal always produce hydrogen, so we can also use water to produce hydrogen in the laboratory. We can actually do that. Reaction with oxide, that is water reacting with oxide. Oxides can be metallic oxide or non-metallic oxide. For metallic oxide, mostly the basic oxide, if we dissolve in water, it is going to give us alkaline solution and still liberate hydrogen. For oxides of non-metal that are acidic, you remember I said something about acid anhydride when I was discussing rainwater just now. And if we have something like XO3 as an acid anhydride, if we dissolve in water, it's going to give us tetraoxosulfate 6. This SO3 is sulfur 6 oxide, and NO2 in the presence of water and in the presence of oxygen will give us hydrogen triosonitrate 5. That is for reaction of water with oxides. Now, what will be a test for us to know that there is a presence of water? To test the presence of water, add any liquid to a white anhydrous copper 2 tetraoxosulfate 6 or blue cobalt 2 chloride. Please, this is 2 chloride. If the liquid is water, you will observe the blue color and pink respectively, as you can see on the screen. So the copper CuSO4 is white, but CoCl2 is blue. But when water is added to it, for CuSO4 it will become blue, but for CoCl2, that is cobalt 2 chloride, it will become pink in color. Now we have treated water based on classification and also treated water as compound. Let's look at water pollution. Here I will not take much of your time here. Water pollution is releasing of harmful substance in water to upset the water, making it unsafe for aquatic ecosystem and for the animal use, where the animal include you and I, because according to biologists, we believe that human being is a higher animal, so it will make it unsafe for even human being to stay here. As you can see, a sample of a video here showing an effluence in water. This is very, very bad. This is a way of water pollution. The substance that contribute to water pollution, we call that water pollutants. Example of them include effluents. Please, this is effluents from industry, either chemical, gases, or energy directed to rivers. We have agricultural waste washed by rain to rivers. We have sewage emptied to rivers, and we have oil spillage, as you can see on the screen. So this is a sample of water pollution. It is not good. So how can we be able to reduce this water pollution from happening on our environment? What are we going to do? Educate citizens and set up laws that prevent the introduction of waste to rivers, and treat sewage before emptying them into rivers. Use detergent on oil spillage. I just want to thank you for watching this video to this extent. There is a question that is uploaded on your Google. Is a Google form question. I would like you to answer those questions and use it to know if you actually grab something. In our next class, we will be looking into solution and solubility. We will be doing question on that. So I will urge you to read solution and also read solubility. See, you can watch this video up to 4 times. Watch it up to 4 times and listen to it, and make sure you follow around. I believe you have read it, but you have gotten some little knowledge from watching this video. Watch it again and again. Then if you have any question on where you did not really understand, you can ask your questions. Thank you very much for watching.